Oh, g'day and welcome to part 3 of the Nixie clock build. If you've been following this series, you would have seen in the first part I talked about the design methodology for what I call a neo-steampunk type Nixie clock, and I also had a look at the marking out and the manufacture of the timber parts which comprise the clock assembly. In part 2 we explored the making of the flat metal parts. These were CNC machined, and there's a cooling screen and also the bezel which houses the 6 Nixie clock tubes. In this episode I want to focus on the turned metal parts. For the build I want 4 of these assemblies which comprise a leg pillar, a cap and 2 decorative rings. And also we're having a look at making the housing for the hygrometer, which is just a decorative feature of the front of the clock. So I want to go through those processes. Sadly I didn't get a chance to do the metal finishing. I'm going to do that in part 4 of this series. So for now, put your seat back and tray table in the upright position and let's get set for some engineering porn. So with this acrylic tube, I can just feel when I run my fingers that it's not particularly round, so I'm not expecting this to be super accurate. So all I'm going to do here is to face the end, try and get a cylindrical section machined on the end of it, and then cut the thread. What I found is that when you're tapping or threading acrylic, a bit of paraffin wax works as a lubricant. This is just an old candle. I don't really want to put any liquid oil on there, just simply as it's going to get inside the tubing. So I've got my 5/16 by 40 model engineered die in here, and I'm just going to very gently get this thread started because it's got a tendency to chip. So you just got to listen. Seems to be once you get it started it's fine. Okay, so we've got a thread. What I'll do is just at the end of that thread I'm just going to relieve that with a bit of an undercut. This is a tool holder I made for narrow parting blade. This is actually a jigsaw blade, and it's just clamped at the end of this block here with a couple of big headed screws. It sort of works pretty well. It's mainly where you want to part off things like little tiny washers and so on, and you don't lose a lot of material. So I'm just going to put my thread relief in there. And then we'll just do a chamfer on the end of the thread. I'm just going to part this off pretty much well oversized at this stage, and I'll trim to length later. Once again, that wax works really well when you're parting off on acrylic. So that's done. So I'll just wait till I got my little neons and I'll work out how far they go up and then just cap that somehow. So to get this threaded acrylic tube into the bezel now, I'm going to drill a tapping size for a 5/16 by 40 model engineer thread, and the chart shows 9/30 seconds as our drill size, and then we'll tap the thread. I'm just going to countersink this slightly too to get the thread a chance to start. Years ago I built one of these George Thomas tapping and staking tools and also the sensitive drilling attachment that goes with it. And although it's a wonderful piece of kit, it just sits there under cover nearly all the time and I rarely use it, but where you want to drill or at least tap a thread and get it relatively square to the surface, this is probably the best gadget that I've got for doing it. It's just so easy to start the tap square, and if I try to do this any other way I can guarantee I'd get it wrong, and the little acrylic tube would sit up all cockeyed and make it look stupid. Alright, let's get the little tube. Yes, lovely. These screws, the heads are just a tiny bit too big for the pockets, so what I'll do later on is to just skim these in the lathe, just take off the bare minimum so they'll fit in the pockets. And I think I'm going to nickel plate those screws just to make it look nice. I think that brass is eventually going to corrode and oxidize and look horrible, so I've got a little nickel plating setup that I'm working on, so I'll do that. So the next thing I'm going to be doing is to make these four pillars that go in the corners and the caps, and I'll get this whole assembly done and then look at the clock, or sorry, the little hygrometer module to go in the front. With all of the timber parts and acrylic parts and the flat milled parts done for the clock now, the next step is to make 4 of these turned aluminium legs. There will be 8 of these decorative rings, 2 for each leg, and 4 of these top caps. All of the stock that I have for making these is, unfortunately, it's just square offcuts and bits of rubbish basically. I don't have any round stock close to the right size, so I know it seems a bit wasteful, but I've turned all of that down into round billets, and from that I'll be able to machine the parts that I need. Like I say, it seems wasteful, but I got tons of this stuff for nothing, so I might as well use it. So one of the next things I have to do is to drill 3 fixing holes in the top of these leg pillars. These will be tapped M4, and later on there will be a cap fitted on top with cap screws to hold it all together. I have several different ways I could do this, so I could probably do it on the CNC mill. I've got a dividing head that I can put on the milling machine, but this is actually my go-to method for most of the radial drilling operations that I have to do. I'll show you the whole setup. So what I have is an old AEG 2-speed drill, and it's fitted to a steel fabrication which bolts into the top side, and it was line bored so that the mounting hole is parallel to the axis of the lathe. I've set my position for the drill centers so they match the drawing, and then it's just a matter of racking the saddle backwards and forwards to drill the holes. For dividing, I've got an attachment which fits onto the lathe spindle, and I'll show you that. The dividing setup is pretty straightforward. There's just a steel collar which is mounted on the spindle of the lathe, and then there's a row of 36 holes at the back and a row of 40 holes at the front. So with those 2 sets of holes I can get most of the common divisions that I need. So I've got a plunger which can be locked out, and you can rotate the spindle and then lock it into a particular hole. And just in case you're wondering, yes, it'd be catastrophic if you turned the lathe on and ran the spindle with that locked, but I always take the spindle out of gear so that if I'm stupid enough to turn the lathe on, nothing will happen. So it's just a matter of dropping the pin into the appropriate hole, that locks the spindle, drill a hole, advance it to the next division, and away you go. The other advantage of this is that I've got to drill the matching holes in the cap, and as long as I don't change the setup, all my holes should match. So what I'll do is I'll center drill all of these pillars without changing the position of the drill bit on the cross slide, and then I'll set up the stock for the caps and I'll drill them without changing the setup. I've just got this set up as tapping size for M4, and I want to drill these holes 10mm deep. So on my DRO I'll just zero that out where the drill bit touches the countersink, and I'll be able to drill them to the correct depth. So it's just a matter of rinse and repeat now with the other set, and then I'll go ahead and drill the stock for the caps. So I've drilled all 4 of those legs now, and they'll be tapped later, M4. And before I change this setup, what I want to do is to pre-drill some stock for the caps. So if I drill this now, drill deep enough, I can part off the slices that I need, and then finish them later by just simply screwing them to one of the legs and machining the radius on that. So I'll be drilling this at 4mm, and I want to go as deep as I can without jamming up the drill bit. Okay, so I just faced that off after the last piece had been parted off, just give me a good finish on what will end up being the top side. So I'm going to part this one off now, and I'm going to use coolant on this, and because it's a fairly deep parting off, I'm going to sort of back the blade out, move it over about 5 thou, make a partial cut, come back just to give me some clearance. So I've had these things break on me before when they jam up. So wish me luck. Cool, 2 to go. So these are the decorative rings that fit on the legs of the Nixie clock, and I've got 8 of these to make, so one top, one bottom on each leg. This one's finished. I need to put this radius around the edge of the ring, and I've got the 8 blanks already made up like that, and they've been bored to fit the pillar, the leg. So just to make the setup simple, I've made a fixture that's fitted to the 3-jaw chuck, and each of the blanks can fit on that spigot and just held in place with a socket head screw and a cap, so that it's just a repeatable setup. And I've got a radius turning attachment. So the radius turning attachment is one that I made on my CNC mill, and this was really pushing the limits of what that mill could do. But it follows the standard pattern where the tool bit is able to pivot around a central point, and I've already set the radius on that tool tip. So I'll just get this set up. And the other thing was that this tool, just by sheer dumb luck, turned out to be almost exactly the correct size. It's just a tiny bit oversized, so if these rings were designed any bigger, I wouldn't have been able to make them at all. Today I want to try and make a housing for this little hygrometer. It's going to fit in the front of the clock, and I've got a drawing here that shows that it's just basically a cylinder. These things got a little silicon gasket on the back of them, so that there are projecting ribs, so when you get close to the correct size, press that in, it'll just compress and hold that in place. So I'm happy that that's the right size. So I'm just going to trim up the outside. Okay, so what I want to do now is part that off, and I'm using a 3/32 wide inverted parting tool. If you do want to get a bit more precise about it, and just touch off on that feeler gauge. Then I know that my parting tool blade plus the feeler gauge is about 93 thou. So all I do is advance my top side by 93. Then I zero my DRO offset 10 millimeters. And of course, this parting tool being inverted, I've got to run this in reverse. There we go. So, well, I'm going to call this episode finished at this point. In the next episode, we're going to have a look at all of the metal finishing processes and hopefully the final assembly. So for now, if you like the video so far, please make a comment. Please don't be afraid to share it with other people. Quite frankly, I'm after all the exposure I can get. So for now, thanks for watching. God, I could watch this thing all day.